Hello friends, today's topic is bias clipper in which you are facing some difficulties. To solve them, watch this video till the end. Because in this video, I will give you some tricks by which you can solve any clipper circuit within 1 minute only. Friends, only 1 minute. So focus in this video. First of all, consider about the previous topic is unbiased clipper or basic clipper. So first of all, consider the parallel clipper. So in case of parallel clipper, positive output will be not available. In case of negative clipper means negative output is not available. So in case of without bias, always zero voltage will be there. So in case of bias clipper, you have to count your bias and supply voltage to find out your starting voltage. In case of without bias, your starting point is 0. In case of bias, your starting point 0 or it will not be 0. So first of all, you find out the starting point of your waveform. So first of all, consider in this case, in case of positive clipper, for the bias condition, you have to add one DC supply or one battery series with diode. So there are two possibility. Upper plate is positive, lower plate is negative. Upper plate is negative, lower plate is positive. So in case of positive bias parallel clipper, there are two types: upper plate positive or upper plate negative. So consider first theory. So whenever any kind of circuit is available, so consider input is equal to 0 initially. So there is no any kind of input is present. Consider the supply voltage and find out D is on or off. So in this case, consider this terminal is anode and cathode. So cathode is +1 and anode is 0. So anode is lesser than cathode, hence D off. D off means there is no any kind of part available. So input is directly equal to output. So input is 0, output is 0. So your waveform will be start from 0. So initially your diode is off. Diode is off, then input equal to output. So then think about the second point where it on. So consider that cathode is +1. So anode is lower at 0. When in case of positive half cycle, anode is +1, +2, +3, +4, +5. So at which position diode is on? So consider anode at +1.7. So anode is higher than cathode, 0.7 volt. So diode is on. So when D is on, draw the equivalent diagram like that. Diode voltage is 0.7, battery voltage is 1. Anode terminal plus sign, cathode minus, battery plus and minus. In this series condition, plus minus, so addition of these two voltage 0.7 plus 1 is equal to 1.7. So you can find the answer like that. So your waveform from 0 to 1.7, D off, and 1.7 to a maximum voltage D on. So 0 to 1.7 volt D off and 1.7 volt to 5, your maximum input D is on. So 0 to 1.7, so 1.7 up to this, so input shape will be represented at output voltage. And after that, constant voltage will be generated. This voltage is, you have to mention over here, plus 1.7. So in case of negative cycle, cathode is positive, anode is negative because all voltage are negative, -1, -2, -3, -4. So diode is off. Diode off, so output equal to input means all negative cycle will be as it is. So consider positive clipper, so only reflection in positive cycle. So negative output is -5. So whenever any kind of battery will be added to diode in parallel clipper, so upper plate is positive, then 100% your voltage is shifted about 0 to positive side, not negative side. This is a trick. Plus plate means upper plate is plus, then your voltage will be shifted from 0 to upper side only, and the upper side voltage defined by addition of these two battery. Diode is a 0.7 volt battery and this is a bias battery. So in case of the second configuration, Consider initially the first parameter. Consider input is equal to 0. Find out D on or find out D off. So first of all, consider anode and cathode. So cathode is equal to -1 and anode is equal to 0. So anode is positive than cathode. So diode is on. When D is on, draw the equivalent diagram over here. Anode make plus plate, cathode make minus 0.7 volt, and battery is minus plus 1 volt. So in this case, plus 0.7 minus 1 is equal to minus 0.3 volt. So your waveform will be start from minus 0.3, not 0. So this is your starting point. So your waveform is started from minus 0.3 volt. So in this case, cathode is minus 1 fix. Anode is in positive cycle, plus 1, plus 3, plus 2, plus 3, plus 4, plus 5. So all these case, anode is higher than cathode. Anode is higher than cathode. So diode is on. Diode is on in whole positive cycle. Constant output voltage is 0.3. The first configuration will be available. So in all positive cycle, constant output voltage 0.3 will be available. So in this case, second case, D off. So consider in the negative half cycle, anode is -1, -2, -3, -4, -5. So in this case, the output voltage, so here is -1. So anode is 0. Then D is on. Anode is 0. -0.1, -0.2, -0.3, -0.4. So -0.4 -1. So there is a difference only 0.6. So minimum difference to turn on the diode is 0.7. So anode at -0.4, diode is off. So up to -0.4, constant voltage will be generated. And then diode is off. Diode off means output is equal to input. Then after your negative cycle will be start. And it will not reach at the 0. It will stop at again minus 0.3. So maximum peak amplitude of negative cycle is 5. So in this case, your upper plate of bias is minus. Your voltage will be shifted from 0 to minus. In this case, 0. So voltage is initially without bias is 0. When upper plate is minus, your voltage shifted in minus. The output output voltage will be defined by calculation of this part only. So in this case of negative clipper, first of all think about the without bias. In case of without bias, negative clip means negative is equal to 0. So in this case, there are again two configuration. Upper plate is positive, upper plate is negative. Let us start with the first negative bias clipper. Again the same question. First input consider is 0. Then think about D on or off. Here lower is anode and upper is cathode. So anode is equal to +1 and cathode is equal to initially 0. So cathode is lower and anode is higher. So diode is on. When diode is on, draw the equivalent diagram over here. So lower plate anode. So lower plate is plus, upper plate cathode minus. Diode voltage is 0.7 volt. And the bias voltage is upper plate plus, lower plate minus. Minus 0.7 plus 1 is equal to plus 0.3 volt. So your waveform is started at plus 0.3 volt, not at 0 volt. So your waveform is started from plus 0.3 volt. So initially D is on. So think about D off. The second question is D off. So initially anode is +1. Cathode is initially 0. So input voltage is rise from 0 to +5 means 0.1, 0.2, 0.3. When cathode is equal to 0.4, the difference between anode and cathode is 0.6, hence D off. So at 0.3 after any voltage in positive cycle, D is off. When D is off, output is equal to input. So in this case, after 0.3 cycle will be represent as it is. But your waveform is start from 0.3 plus 0.3, not 0. And it will end to plus 0.3, not 0. Okay. So in case of negative cycle, cathode is -1, -2, -3, -4, -5. So anode is plus and cathode is minus. Definitely D is on. D is on. The output voltage is constant 0.3. So this 0.3 voltage will be constant in all negative cycle. So in this case, initially without bias, your negative level is 0. When upper plate positive, your voltage shifted upper side. This is a trick. And this voltage is defined by some simple calculation of these two bias. Diode is a one kind of 0.7 bias and this is a 1 volt bias. Consider about the next. In this case, minus plate upper side, lower plate is plus. Consider input is equal to 0. Then think about the first case, D on, D off. Here anode and cathode. Initially anode is minus. Anode is minus. So initially cathode is equal to 0. So cathode is positive compared to anode. Hence D off. So in all positive cycle, cathode is +1, +2, +3, +4, +5. Hence in whole positive cycle, diode is off. Diode is off. Output is equal to input. So input is equal to +5. Then output is equal to +5. Sorry, in this case upper voltage is +5. Okay, so then think about the next case, D on. So in this case anode is -1, so cathode is initially 0. So in negative cycle cathode is 0, -1, -2 up to -5. So minimum amount of cathode voltage to turn on this diode is -1.7, because -1.7 is lesser than -1, and the difference between -1.7 and 1 is 0.7 to turn on this diode. So when diode is on, draw the equivalent diagram. Lower plate anode is plus, upper plate cathode 0.7 volt, and the battery minus plus 1 volt. So calculation, -0.7 minus 1. So total voltage is -1.7. The answer will be match with your desired voltage. So up to -1.7, D is off. So D off, so input equal to output. So consider this is a -1.7 point. So up to this, input equal to output as it is. And then after 1.7 -1.7 continue, DC voltage available your negative half cycle. So you have to mention over here -1.7 volt. So in this case, upper plate is minus in parallel bias clipper, sorry, negative parallel bias clipper. Upper plate is minus, so your 0 voltage will shifted to minus side. This is a trick. In this using trick, you can draw any kind of waveform. Just you can calculate your equivalent circuit voltage and you have to mention the voltage over here. Okay. So thank you for that's give me your response if you like this video, so I get to know whether it is accessible for you or not. So my next video topic is bias series clipper. Stay connected. Thank you.